In this quick movie, I'm going to show you how to draw what's called a chair structure. I'm not going to explain too much about the background of what the chair structure is. In addition to this video, I'm going to attach a link to a YouTube movie that somebody else made about drawing chair structures. And I'm also going to upload a few documents or templates that you can use as you practice your chair structures. This is a really fundamental technique for understanding molecules with six-membered rings. It's really important that you kind of get good at drawing chair structures very quickly as you proceed through this module. This isn't something that you want to wait until right before the exam to get good at, because it will make it difficult for you to practice some of the problems on the discussion set. So again, the focus right away should be to learn how to draw chair structures without kind of screwing up too much. Try to make them look as good as mine. I know it can be done. Okay, so let's get into it. Let me find my window here. Okay, so what we're going to need to draw is a chair structure. So chair structures, these sound a little weird, and they're going to be counterintuitive until we really get into the chemistry of six-membered molecules. So chair structures, I will provide one blip of context and definition for you, but then I'll leave that to future lectures. But chair structures are depictions of the conformations of six-membered rings. They're nice because they're accurate. After these first few lectures, they're easy to draw. And they're highly relevant. So this isn't something that I teach you and then like after module 3 you never use anymore. That's not the case. Chair structures are critically important for understanding six-membered rings, and six-membered rings are the most important molecules. With six-membered rings are some of the most important molecules by far. In a way, the most important ring size is the six-membered ring, and so all of this is really important for understanding molecular science. Okay, so what does it look like? Well, a chair structure looks like this, or it looks like this. And I guess we call them, and don't worry if you weren't able to draw it, that's sort of the purpose of this lecture, the YouTube video, and the kind of template worksheets that I'm going to provide. But it looks like a chair, sort of, if you draw a person sitting in the chair, I guess. Anyway, that's where the name gets, that's where we get the name. So there's kind of two versions. One where there's sort of a left-handed side pointing upward and a right-handed side pointing downward. So what is this? I mean, maybe you can kind of see that it looks like one of those chairs that you would put poolside or something so that you can kind of lounge or lean back in. But what is it that we're actually doing? Well, I said we're trying to draw six-membered rings in a more accurate depiction. So what we can do is redraw this in with a three-dimensional depiction. So I just show a simple hexagon. And for the most part, these simple shapes work out well for us to understand molecules. But because six-membered rings are so abundant, so important, and actually kind of special in a lot of ways, it's important for us to look at how they're actually depicted in 3 dimensions. And what we do is that's where one of the two versions of the chair structure comes in. So just like any other bond line structure, every corner in this shape is a carbon. So there's a carbon there, 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 and I'll just kind of wind around. Oh, wait, I got them all, didn't I? Okay, never mind. So yes, I see now there are 6 arrows. Anyway, there are 6 kind of corners to this shape. That is a carbon. So what you want to be able to do is draw the 2 versions very quickly. And then after you're able to draw the 2 versions, I want you to be able to add groups to the 2 versions appropriately. And that's going to rely or require us to really get good at the fundamentals of drawing chair structures. So First things first, drawing a chair structure. Um, I'll lay out some steps here, but hopefully, again, I keep emphasizing this. Hopefully, after a while, you just kind of get fast enough to where you just draw it and it looks reasonable without thinking about the steps. But we'll start. Okay, so step one, what we want to do is we want to draw the middle slanted lines. Now, the trick with chair structures, and again, these things are accurate depictions of six-membered rings in nature, in the universe. Um, but kind of a nice trick about them is that they have slanted lines. And these slanted lines are parallel to another slanted line across the ring system. So we could draw, and maybe the first two that I draw were a little bit too slanted. It doesn't matter so much, but I'm going to kind of draw these slanted lines offset of each other. And so what I'm drawing here are three chair structures, just because I want to practice and look that these things are molecules, so they can kind of rotate and flip and twist around. We want to be able to kind of be able to work with them. Okay, so we've got these starter lines here, and then what I want to do, and you'll get as sick of me saying this word uh, as I will be as sick of saying this word, but we're going to draw the flaps, and I would draw the left flap. And so with the left flap, what you do is you start with your parallel lines, and I'm just going to grab these. Maybe if you're drawing the steps, you just practice. Let's see. Sorry. So I've got my lines here. You just redraw them probably. What I want to do is draw on the left side of the molecule a flap. Now a flap should connect the right two lines, and if the top line in each case, the top line is going to kind of define the opposite direction that the, or I guess either line, but I usually focus on the top line, is going to define the opposite direction of where the flap is going to be pointed. So that is to say that if you look, it looks like this is pointed up, down, up. And so as a result, my left-handed flap is going to be pointed in the opposite direction. So this is down. We have an up left-handed flap and a down left-handed flap. Yep, I see it too. I said up, I meant, or I said, yeah, I said up, I wrote down. Okay, let's fix that. So those are the left flaps. So draw the left flap, and then step 3, we'll draw the right flap in the opposite direction. Now, the YouTube video that I'm going to post has a slightly different approach to this, and I think that's great if either approach. We just have to get to drawing chair structures quickly, and this is just one of those things where, you know, when you've done this long enough, you've drawn enough chair structures, you recognize that I have no problem if somebody says, well, I learned it better from the YouTube video. I think that's fine. We just have to get to be able to do chemistry with these things. Okay, so that was the left flap. I'll add that in all cases. Okay, now the right flap is going to go in the opposite direction of the left flap. So if you notice, for the left-handed structure, I had the left flap pointed down, and the right flap now is pointed up. Similarly, I had left flap up, I'm gonna have right flap down. And then once more of another flap. And so take a look at your chair structures. How do they look? if hopefully after a little bit of practice, you get to the point where you can draw these things quickly and that they're also accurately depicted. Okay, so why do we have to draw two versions of the chair structures? Why don't we just stick to one? Well, it turns out that chairs are the two versions of the chair structures are different conformations. So let me ask that question and then answer it. So why do we need two? I know these things can tumble around, but the two versions I was talking about are actually different conformations. So two versions of the chair structure. So the answer to this is that each version is a conformational isomer of the other. Okay, so each version is a conformational isomer of the other one. That is to say, if I've got a chair structure that looks like this, where if you notice we have a left flap pointed up and a right flap pointed down, what I'm saying is that if you do a conformational isomers are molecules that differ in free rotation. What you do is a series of free rotations on one chair structure to get to the other. So I'm going to draw my kind of looping arrow and say the words free rotation over that arrow to indicate that as I go from one chair to the other, I have done what's called free rotation. And the relationship between these two structures are conformational isomers. And in particular, these are, quote, chair flips. So we're going to be doing a lot of chair flipping, which I think is kind of fun. I mean, it's just at least fun to say, but we're going to be doing quite a bit of chair flipping as we move between the various conformations. Okay, so I think that's a good place to stop here. So again, hopefully this video, in addition to the YouTube video, will allow you to kind of practice getting good at drawing chair structures. That's a skill you want to get at quickly. And if you'll notice, there's just a small assignment associated with this, just a few points. Hey, send me a picture of 10 chair structures that you drew. I just want to make sure that you're doing this and doing this early, even though it's fairly easy. And it also allows me to provide some feedback and say, hey, these aren't, for some people, I'll be like, hey, these aren't looking good. Let's practice a little bit more so that way we can take effective notes and useful notes as we go through the rest of the lectures for Module 3.